Hi, good morning. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. And today, in our video lecture series, we are going to discuss about the gate drivers topic, which comes under the Unit 3, that is drivers for wide bandgap devices. Come, let's get into the topic. So, what is actually a gate driver? A gate driver is a powerful amplifier that accepts a low power input from a controller IC and produces the appropriate high current gate drive for long power devices. As requirement of power electronics continue to increase, the design and performance of gate driver circuitry are becoming very every ever more important. So power semiconductor devices are the heart of modern power electronic systems. These systems utilize many gated semiconductor devices such as an ordinary transistor, FET, BJT, MOSFET, IGBT, and other as switching elements in switched mode power supplies, universal power supplies, that is UPS, and motor drives. Modern technology evolution in power electronics has generally followed the power semiconductor devices. Power level requirements and switching frequency are increasing in the power electronics industry. The metal oxide semiconductor field effect transistor, that is MOSFET, and insulated gate bipolar transistor IGBT are two of the most popular and efficient semiconductor devices for medium to high power switching power supplies in the applications. Here we can see the symbols for MOSFET and IGBT. So in MOSFET, there are three terminals, that is gate, drain, source, that we know already. So gate is used to control the current flow between the source and drain. And another one is IGBT symbol is gate and collector and emitter. So the gate of the MOSFET or IGBT is the electrically isolated control terminal for each device. The other terminals of these devices are source and drain or emitter and collector. To operate a MOSFET IGBT, typically a voltage has to be applied to the gate that is relative to the source emitter of the device. In order to drive these switching devices into conduction, the gate terminal must be made positive with respect to its source and emitter. So the power device switching behavior is affected by the parasitic capacitance between the three terminals, that is gate to source, that is CGS, and gate to drain CGD, and drain to source CDS, which are usually non-linear and a function of bias voltage. Charging the gate capacitor turns the positive device on and allows current flow between its drain and source terminal, while discharging it turns the device off, and a large voltage is blocked across the drain and source terminals. The gate voltage of power devices does not increase unless its gate input capacitance is charged, and the power device does not turn on until its gate voltage is the gate threshold voltage, that is VTH. The VTH of power devices is defined as the minimum gate bias required for creating a conduction path between its source and drain regions. For operating a power device as a switch, a voltage sufficiently larger than VTH should be applied between the gate and source terminal. So in the high power applications, the gate of the power switch can never be driven by the output of a logic IC. This logic IC is PWM controller. Because of the low current capability of these logic outputs, charging the gate capacitance would require an excessive amount of time, most likely longer than the duration of switching period. Hence, dedicated drivers must be used to apply a voltage and provide drive current to the gate of the power devices. So this can be a driver circuit, and it may be implemented as dedicated ICs, discrete transistor or transformers. It also be integrated with PWM controller. So a generalized layout of power electronic system is given over here. So here we have a control circuit, and the gate driver is there, and power controller, power converter, and finally it will be delivered to the load. So a gate driver is a powerful amplifier that accepts low power input from a controller IC and produces appropriate high current gate drive for power devices. It is used when PWM controller cannot provide the output current required to the drive the gate capacitance of the associated power devices. The gate driver circuit is an integral part of power electronic systems. Gate drivers form an important interface between the high power electronics and the control circuit, and are used to drive power semiconductor devices. The output of DC-DC converter or SMPS mainly depends on the behavior of the gate driver circuits, which means if the gate driver circuit does not drive the gate of the power devices properly, the DC-DC power converter output will not be according to the design requirement. Therefore, the design of the gate driver circuit is critically important in the designing of power electronic converters. So types of gate drivers. So low side drivers used to drive ground reference switches. That is low side switches. That's the symbol on the circuit diagram is given over here. High side, low side drivers. That's used to drive two switches connected in the bridge arrangements, both floating and ground reference switches. So gate driver isolation, it means that in many application of power devices require an isolated gate circuit. For example, in power converter topology such as half bridge, full bridge, buck, and two switch forward and the active clamp forward. These are the high and low switch because cannot be used for directly for driving the upper power devices. So here the floating supply level converter gate driver circuit 1 and 2 is given. So this is the circuit diagram. Thank you.